Ya udah. Udah. Oke. Assalamualaikum warahmatullahi wabarakatuh. In this video, we will present a case study from the previous meeting. And the member is me, Muhammad Maulana, and Faisal AZHAR Ramadan, and MAJD AL-MUNTASER. Okay, for the first question is presented by MAJD.
Okay, for the first question, it is determine the effort exerted to move a circular particle C in the XY plane with a radius of 3. The direction of the article is counterclockwise. The force action F equals 2x minus y plus z times ax plus x plus y minus z squared times ay plus 3x minus 2y plus 4z times az. Equation of the circle CR U and V equals R cosine theta and R sine theta. So the solution is R equals 3 cosine T I plus 3 sine G dr equals negative 3 sin Ti plus 3 cosine Tg, the derivative, and then we have x equals 3 cosine T and y equals 3 sine T and z equals 0 because it's a circle. FCR for U and V equals 2x minus y and x plus y. So we find the integrate CF equals the integral of 6 cosine T minus 3 sine T derivative plus the integral 3 cosine T plus 3 sin T times 3 cosine T equals then the integral C negative 18 cosine plus sin T plus 9 cosine squared T plus 9 cosine T sine T dt. Equals the integral from 0 to 2 pi for negative 9 over 2 sine 2t plus 1, the derivative, equals negative 9 over 2 times negative cosine 2t over 2 plus 1 for 0 from 0 to 2 pi equals 1 plus 2 pi minus 1 equals 2 pi, which is the final answer. This is for the first question. The second question is, take a look at figure 1. dq has an electric potential dv with a trajectory of the scenic line equal to negative 1 over 4 pi e0 lambda dl over r. The length of the arc element dl on the circle is r d theta. If the ring lambda is 5 nc over m, the distance r is 4, then the distance z equals 0. Calculate the electric potential at point A, 0.0, 0 and 0 and 10, caused by the charge disruption in a vacuum. E0 equals 8.85 times 10 to the power of negative 12 c squared over n m squared. And this is the figure here. So for the solution, we have dv equals negative 1 over r lambda e0 lambda over r. We have now lambda equals sin over m and z equals 0. dA equals lambda r d theta, r equals u, r equals the root of r squared plus z squared, lambda equals 5 times 10 to the power of negative 9, c equals sin over m, yeah, equals the integral of from 0 to 2 lambda dy for dA over r equals the integral from 0 to 2 lambda negative 1 over r lambda e0 lambda r d theta over the root of r squared plus z squared equals negative lambda r over r times e0 r, the integral from 0 to 2 lambda d theta. xa equals negative lambda r over r lambda e0 times the root of r squared plus z squared, all of this times 2 lambda. va equals lambda r over ter equals negative 5 times 10 to the power of negative 9 c over m times 4 over 4 times 2 times 8.85 times 10 to the power of negative 12 c squared over x times n squared, which equals approximately negative 282.48.
Okay, and the next question, number 3, is take a look at figure 2. The DQ has a electric potential VR on this trajectory equal to negative 1 over 4 pi E naught double integral theta r accent over r vector dA, and the element area on the disk is r dr d pi. If the ring theta is 2 nanocoulomb over m and the r is between 0 and 4, then the distance z equal 10. So we calculate to calculate the electrical potential at point A0010 caused by the charge distribution in the vacuum. The constant electric is 8.85. So here the figure, and the solution is the VR equals 1 over 4 pi E naught with the formula here, and the Z is 10, the constant E naught is 8.85, dq is theta dr d theta, and the theta is 10 minus 9, and the A is 10 units. The EP is A0010. Yeah, and we just use the VA, so integral from 0 to theta dr dq over r, and then for integral for r naught, integral to pi theta equals 0, 1 over 4 pi E naught multiplied by theta over square root of r square plus z square multiplied by r dr d theta, and the 10 over 10 power 9 minus 9 over 4 pi E naught integral for r from 4 to r naught, and integral to pi theta 0 is multiplied by 2r over square root of r square plus z square r dr d theta, and we first integrate the to pi, so we get 10 power 9 over by minus 9 for pi 0 a0 to pi integral for r0 1 over 2 to r, and then we integrate the r, so we get the 10 power by 9 minus 9 over 2 in integrate the r squared plus z squared 4 to 0, and we get the 10 power minus 9 over 2 multiplied by the constant and the square root for 2 plus 10 squared, and we get the result is the 608.45 volt. And the next question is find the total charge in the volume defined by x between 0 and 1 meter. Y is also between 0 and 1, and z is also between 0 and 1. If 3 is 50 z square x squared pi, and if dq is p dv. Okay. So the volume we use 3 integral, so the formula is 3 integral e dv. The dp here is dx dy dz dz. So we just plug in integral 1 to 0 1 to 0, and the dx is 30x squared y dx dy dz, and the integral from 1 to 0 multiplied by 10x power 3 y integral 1 to 0 and dy dz, integral the x first and then integral the y, integral y 1 to 0 multiplied by 10y dy dz, and the last is integral the dz. We get 5y squared from 1 to 0 dz. We get 5d dz, and the 5z from 1 to 0 is 5 columns. Okay, Ridwan.
Okay, for the next is the question number 5. A spherical disc of radius 4 meters with charge density D equals 12 sin del theta surrounded by a closed surface S with NdS equals RdR d theta. What is the total flux through S? So the answer is Q equals integral R equals 0 to 4 and integral theta from 0 to pi and dds. So integral 0 to 4 and integral 0 to pi 12 phi sin theta d theta and dr equals 12 integral r equals 0 to 4 and integral theta equals 0 to pi to p and r sin theta d theta dr and equals 12 integral r equals 0 to 4 r minus cos theta from theta equals 0 to pi and dr. So equals 12 integral r equals 0 to 4 rdr and equals 12 times 2 integral r equals 0 to 4 dr and equals 24 1 over 2 r power by 2 0 from 4 and equals 24 times 8. So the answer is 192. And the last Q equals Q include over EO equals 192 over 8,8 R times 10 power by minus 12. So the answer is 2,169 times 10 power by 9 that 13 nm to power 2 over c. So the next question is, what is the net flux through the closed surface as in figure 3 that contains a charge distribution in the form of a plate of radius 4 meter with density ds equals sin square theta over 2r and ds equals RDR d theta. So the answer is ds equals sin square theta per over 2r, and ds equals RDR d theta, and q equals integral 0 to e and integral 0 to 4, and sin square theta d theta. So the answer is integral 0 to 4, 1 over 2 sin square theta dr equals 1 over 2 sin square theta integral 0 to 4 dr. And the next answer is 1 over 2 sin square theta n equals 2 sin square theta, and integrals 0 to 2p to sin over 2 theta d, it's dt, right? dt or drc ini? Ya, di dr, and q ya kan, di q equals 2p, so the net flux equals q per eo equals 2 pi over 8,885 times 10 power by minus 12 nm square and c square. So the answer is 10 times 10 equals 11 over 11 power 11 nm square and c square. Okay, maybe that's all from our group, and sorry if there are any mistake. Wassalamualaikum warahmatullahi wabarakatuh.